Hey there guys, in this video I want to focus only on the In this video I want to focus only on the I might as well restart, that was stupid. All right. 1, 2, 3. Hey there guys, in this video I want to focus on the universal gas law constant. In honors we used it as 0.0821 liter ATM over mole Kelvin. The IB data booklet will give it to you as 8.31 Newton meters per mole Kelvin. You may also see it in physics given as joules per mole Kelvin, because a joule is the same as a Newton meter. And then another form that I find comes in handy a lot, but the book doesn't actually give you, is 8.31 kPa decimeter cubed over mole Kelvin. So first thing I want to do is to prove that the honors number is the same as the IB number, and then also show you how to derive from what they give you into the kPa version, in case you need to get it and can't remember exactly what it is. So first let's start with this conversion from honors to IB. So starting with 0.0821 liter ATM over mole Kelvin. Now notice the bottom doesn't change at all. So we're really just focused on the top, liter ATM, and I want to get that into something with the Newton meter. So the first thing that I notice is with my conversion factors, I have Newton meter that does tie to a pressure. 1 Newton per meter squared actually is equal to 1 Pascal. So if I'm having atmospheres, I would try to get it to pascals so that then I can get towards the Newton something that I want. So let's try that first. Let's put ATM on the bottom and pascals on the top. Then the next step is going to allow me to put pascals on the bottom and bring in the Newton per meter squared, I should say. Bring in those Newton and meter numbers at least, or units at least. So I'm headed in the right direction, kind of. Now liters isn't going to get me anywhere, so I should probably do something about that. Put liter on the bottom. I'm going to go ahead and erase this joule per Newton meter. I already made that point. We don't actually need that conversion factor, just to tie it into physics for you. Now if I get rid of liters, where could I go that would be getting me closer to units I want, things with Newton and meter in them? Well, remember a liter and a decimeter are about the same thing. And you see that meter in there? Maybe there's something we can do with that. So let's take a step back and kind of see what we have left. So what have we canceled so far? Actually, let me do this in another color. My atmospheres cancel. My pascals, oops, I forgot to write the A. Pascals cancel. And then I kind of run out of steam. Now my liters cancel. So I've got my mole Kelvin still, and now I have a Newton, a meter squared, and a decimeter squared. So the thing that's closest to canceling at this point is my meter and my decimeter. So maybe I could go ahead and get my decimeter over into meters. So we would need one more conversion factor, decimeter cubed to meter cubed, which is going to allow my decimeters to cancel. And now let's look at what's going on with the meters. I actually have Newton per meter squared, meaning the squared meters is actually in a denominator, whereas the cubed meters is in a numerator, meaning that 2 meters would cancel, leaving a single meter on the top. So what's on top now is both the Newton and 1 meter, which is what we want on top for our IB unit. Now let's think, what numbers would we plug in? My Pascal to atmosphere conversion I had written up here, 1.01 times 10 to the 5th, and then with 1 atmosphere on the bottom. Now this was just a 1-to-1, just kind of the key between bridging the units from pressure to force. And then it was decimeters cubed is the same as a liter, so again 1-to-1. Now this one can be a little bit tricky. I know that 1 meter is equal to 10 decimeters, but if I cube them, 1 meter cubed is actually equal to 1,000 decimeters cubed. So we're going to divide by 1,000 there. So math-wise, we're going to multiply 0.0821 times my Pascal number here, 1.01 times 10 to the 5th, and then divide by 1,000. And actually using these rounded numbers, you get slightly less than 8.31, but the actual number should be 8.31, and what's left on top is Newton meters, and on the bottom, mole Kelvin. So we've transitioned from honors to IB. It's really the same universal gas law constant, just with different units. Now, what if my pressure's in Pascal? Is there an easy way to convert this R that's given into an R that contains kilopascal? And yes, there is. So the first thing that I want to address is the Newton in the meter, and how did I get back towards a familiar unit of pressure? So that was this key conversion factor here. So if I multiply that by Newton, what do I want? I want pascals to be on top. So I want to put the Newton over the meter on the bottom. And I know it doesn't cancel perfectly, so let's kind of look at what does cancel first and kind of clean this up. So a Newton on top will cancel with a Newton on bottom. So that's progress, right? What's left on top with my 8.31 is still a meter and a Pascal. And then in the denominator of the denominator, I have 2 more meters. Well, if something's in the denominator of denominator, it really is in the numerator. So that means I actually have 3 total meters on the top when you combine these. So the real unit that I want to deal with is a meter cubed and a Pascal, and try to get that to convert. So I'm going to kind of start fresh there. 8.31. It just kind of looks funny. I'm going to flip them back. PA meters cubed over the mole K. So now that I have pascals and meters cubed, it's a much closer leap to get to kilopascals and decimeters cubed. Just one conversion factor needed for each. So first the pascals I'll put on the bottom and put kilopascals on the top. Then I have meters cubed, which I'll put on the bottom, and put decimeters cubed on the top. Trying to make sure things cancel correctly. Now there are 1,000 pascals per kilopascal, and then like we looked at over here, 1 meter cubed would be equal to 1,000 decimeters cubed. So not only do my units cancel, Pascal and meters cubed, leaving kPa decimeters cubed, but the 1,000 also cancels. So it's the same number with these new units, 8.31 kPa dm cubed over mole K. And that's how you would convert. So the key conversion factor that's helping us get in between like pressure and forces is that 1 Pascal is equal to 1 Newton over meter squared. That's kind of how pressure relates to force. So when you do that and you simplify up, considering like a reciprocal action here, you get your meters cubed, which is how you can get to decimeters cubed. And then Pascal to kilopascal is just your metric conversion. So we've done it. We've proven the honors number is the same as the IB unit number, and we've shown how to get to maybe a more user-friendly version of the universal gas law constant. The most important thing to keep in mind is that whatever your R value is going to determine what units you have to use for the other variables. So make sure you adjust your pressure and your volume to match your R square, not R square value, your R value, your gas law constant value. All right, guys, that'll do it for our little lesson on converting R. We'll see you next time.